This video will use P52 and 53 from Engineering Design and Graphics with SolidWorks. Make the assumption that you have viewed the videos for sketching relations, setting up your work area, and have a basic understanding of creating parts. Our topics we'll cover is we'll create the three items. This project has a total of eight projects that are available in other videos, and we're going to keep this to the simple side of we'll make the three pieces that we need: the C bracket, the quad plate, and over here the 20 millimeter peg. The other topics then will be general drawing, probably without a template, and then discuss a little bit about what's involved in making templates, and then exporting for 3D printing, and some very basic simulation. So we'll get started with our sketch. This is in metric, and I will fly this out of the way. Go to new, and I'm going to use the standard templates. So one of the things to be aware of, if you have the templates in the tutorials, I've modified my folders a little bit. So when you pick a part and we come in, you want to go to the lower right and make sure that you are in the correct units, millimeters, grams, and seconds in this case. Across the bottom, I see that my filters have popped up, so that is F5 on the screen. If you see those, and there are some items that will go into to filter that you would want to be aware of. So I'm going to leave those there. Cameras are on. I'm not sure what that one is, so I'm going to go ahead and turn it off. Maybe not. All right, so we can manipulate the screen to a certain extent to work within our area. All right, so first is the sketch. I haven't created a folder yet to save all of my files, so we'll do that when we save the part. Front plane sketch, or go into sketch with the front plane selected, and we notice that we have the red origin, and we're ready to start sketching. So one item will be connected to the origin, in that case the endpoint of our line. I'm watching for those inferences as I go through the process, and the height is 50 millimeters, which means that we can offset to the interior, or if we're going to sketch the rest of the geometry, 40 millimeters on the length. And then if we're going to sketch the rest of the geometry, we would just continue to draw lines. Okay, so Control select to make vertical. All right, or select Control to select to make equal. Either one of those will get you to the desired result. So if I stayed in line command and drew the interior geometry, I could achieve the same result as the offset. Our thickness is 10 millimeters, and we're going to reverse the preview to the inside. I do want to cap the ends. Arcs are going to make them rounded, don't help us, but lines will close it off. So we'll go ahead and accept. And then I have to make the choice of, is it going to be an advantage to have this extruded midplane or in one direction. So our width is 30 millimeters. And if I go to midplane, that may help and may not. So we'll have to see, but be aware that you have those options in the direction to make your choices. Next decision is the hole through the part. This is pegged together. When we do the simulation or the assembly, we may see that the rotation on this, we want to choose a different fastener. If there's a possibility that we would go from a through hole, a clearance hole, to a countersink, to a counter bore, to a threaded hole, then we would want to use the hole wizard. So for this, we'll go hole wizard, and we can stay with the simple. There was a previous value, so it can go ahead and reset. And we're metric. I'm going to get away from the dowel holes and go to drill sizes. And the size will be 10 millimeters. So we'll scroll down through, keep going, there we are. 10 millimeters and up to next. All right, so I'm building in some design intent by saying that if I need to change this to a threaded hole, to a fastener, or one side opposite, that I will do each of these items individually. All right, otherwise I could draw the circle, extrude it through both sides, draw the hole on the end, and be done. All right, this is going to stay centered, so select Control Select back to the origin makes it horizontal. And then my dimension from the end, and since that was pre-selected, those items were already in place when, or already selected when I hit the dimension, it's going to jump directly into the dimension command, and I either have to escape out of it or get to the next selection. All right, so 15 millimeters, and that puts it in place. I'm going to hit, well, I don't remember if I hit the hole wizard or hit the S key. I'm in the habit of hitting the S key, so let's go back to the hole wizard on the command manager. All of our conditions should be the same. When I set the position, a Control 8 will be normal too. And since can't quite see through the part, we're going to go to Hidden Lines Visible, and that will allow me to place a relation centering on the previous dimension on the other hole that we produced. All right, so what this does then is they will stay in alignment. The two holes will stay in alignment. But if for some reason I needed this to go to a countersink, I needed relief in that geometry, then we would have the flathead screw, and we'll make it big enough that we can see it. The countersink and the rest of the geometry would be facing the right direction. Oh, and it went back to dowel. So drill sizes and 10 millimeter. Double check the position. Okay. All right, so those are in contrast to opening up a sketch, clicking on the face, going to the sketch icon. I'll Control 8 to get normal 2. And we'll set vertical. All right, so I'm using the origin, so I've made a decision now that since I am mid-plane, this is going to stay mid-plane. The other thing that we could do, yeah, I think to keep it centered, we'll probably go to the mid, and we were 50 millimeters tall. So as I drag that back, the vertical is keeping it in its orientation, but I can locate for the midpoint of my center line and add that relation as well. 10 millimeters, features, extrude cut, and I'll stay with the up to next. Now granted, there's probably not anything that's going to interfere, but we'll see where that comes into play. All right, so when I do the save, I need a, let's go ahead and make a new folder. So 5-2. Okay, so some naming that we've decided on. And this is going to be the C bracket. And we'll need to decide if we're going to name this by part numbers BK20-3 or just the generic name. Naming conventions and title block properties, file properties are a discussion that should be had early and often. Notice in the bottom left we have save as copy and continue, save as copy and open. If we were going to reuse this part, and we've already saved it. If we were going to reuse it, save as copy and continue continues with this part. Save as copy and open saves it and opens the copy. All right, so we've got the C bracket. We'll go ahead and hit save. That puts it in the part. I'm going to leave this open, and as long as I don't get, maybe try not to have more than about 3 or 4 parts and maybe 2 or 3 assemblies open. In the window pull down, we'll start to see items accumulate. If you have a machine, computer that is maybe low on resources, you'll want to minimize that down to very few parts open, very few assemblies open, only what you're working with. All right, so file new. We're back into the to the part. Going to double check for my millimeters, grams, and seconds. I'm going to put this in the front plane, although my design intent says I'm looking at this and know that it would be better if this part was laying flat, putting it in the top. But we're going to go through the rotation in the assembly to put it into to orientation. All right, so if you know it's the part's orientation, draw it in that plane. So first choice would be top plane, but for illustration, I'm going to go to the front plane. Open up the sketch, and then we can use a corner rectangle is probably good enough, but if we came off of that corner and out this way, or I'm making the choice with my center rectangle to center the geometry about the origin. All right, so keep in mind that you have those other options available, that not everything just gets related to the corner, and you're kind of stuck with it. Wherever makes sense and whatever you can visualize in the geometry. So 10 millimeters. And we'll double check the dimensions by double clicking, and it's coming towards, so that's fine. All right, so Control 5 verifies I'm looking at the front, and then the side. All right, so let's see, kind of the same thing here. I think I'm going to stay with the hole wizard, and the through hole will be for 10 millimeters up to next, so no near side countersink. I need to double check and make sure that that didn't put that into the C bracket. And notice that if I jump or try to jump over to the C bracket, it's grayed out. So it's not going to let me over there until I get out of this command. All right, so we'll go with the positions. And I'm going to line that up to the origin horizontal. When we go into the to the sketch pattern, I'm picking up the point. And we have a spacing of 30 millimeters. Total of 4 items. And nothing in the y-axis, so we can dimension the X spacing. That will add a center line, and it will also add a dimension. All right, so position, we haven't given it an orientation off of the edge, so I'll pick that, make it 15. All right, any additional dimensions that I add now will over-define, or since, oh, I haven't turned it off, make dimension driven. Yes, if I want to see it for reference, and then just remember that the grayed out dimensions are driven dimensions and are not affecting the geometry. And we'll go ahead and hit OK. So same thing, if my eventual design ends up with a, I'll go to the M10 this time, and up to next, it's easy to change it over to another tool geometry. So I'll edit the feature, and maybe not as easy to change it back if it does what it did last time. All right, so I'll stay off the dowels, drill sizes, 10 millimeters. I'm not sure why that's reverting other than we changed out of it. All right, 10 millimeters, and we'll turn off the near side countersink. All right, so go ahead and save this. This is going to be my quad, or my plate quad, and save the part. So I'll jump back into the C bracket, looking to see if that last part had the head clearance, so no near side countersink, and 10.5 would be a 0.25 millimeter, which should be visible in that, that setup. All right, so we have our two pieces. New part, millimeters, grams, and seconds. And the peg would be easy enough to draw as a circle and extrude it out 20 millimeters. We don't have a lot of revolves, so if you want to create the peg as a standard, draw the circle and extrude it out, that's fine. I'm going to illustrate this as a revolve. All right, so center line, and my fingers were ahead of me again, so center line, vertical, infinite length, place it on the origin, we'll see that go to black. And then if I am creating, let me just put the height on this, 20 millimeters. If I leave a gap, then I'm creating a ring. And I'm going to go ahead with the side there and make those horizontal, so I have some definition, but the size of the ring is capable of varying. Actually, I think I can get away with putting the 5 millimeters on that. We'll come back to that dimension. Yeah, I have other things I need to say about it. All right, so this goes into revolve, and revolving around the one center line will use that gap as a through hole. When I bring this over and place the corner on the origin, now this will close off, and we'll have the cylinder. Any angle is going to make a conical shape, and any other geometry will participate in the revolve. All right, so back into the dimension then. If I pick an object and the center line, not two objects, so object and object will just give me that linear distance. If I pick the center line, then I have on the opposite side of the selection the diametral, and on the and in between the radial. So I want to take advantage of that diametral, and now when I go in and revolve, we're at 360 degrees, that's my peg. So there are going to be times where geometry is going to be more convenient. Oh, that was 20. And let's see, usually the diameter would come first, so 10 by 20. The geometry, if I was to stack more complicated geometry into place for a part, I could do the same thing out of one sketch with for a revolve. All right, going into the assembly, we have our three parts. We're not going to chase file properties at this point. There's a whole nother discussion on setting file properties and starting to track metadata. Go into the assembly, and I'm still in inch, pounds, and seconds, which is not a problem just yet. The first part that I want to bring in is the quad plate, and if you go right to the OK, it's going to place this origin to origin of the part to the origin of the assembly. Well, that's not really my desired result, but it does add a fixed relation, and the part doesn't move. All right, so based on the side that I put the points, I would like that to face down if and when I need to change this over to different geometry. All right, so if I locate and then highlight, I can see that this face is carrying the whole wizard definition, and that will drive one of my decisions. All right, so I'm going to float, and I still want this centered about the part. So when I float, that's going to allow this to move. And again, just be careful with the pan, because there's not really a perceptual difference from moving the view and moving the part at this stage. All right, so since my origin isn't turned on for reference, I'm going to come up to the view and turn the origin on, and now I can see the origin for the assembly and verify that I am moving the part or that I am moving the view. Okay, so I can pre-select a face. We go into the paperclip, the mate, and then we'll use the flyout, or we can pre-select both. So top plane, and those were set to coincident, so that should rotate. And I did not rotate. Let's see, did it apply the mate? So under the mates list, there's my coincident. Okay, so, oh, there we go. And just didn't update. So when I drag the part, it updated. All right, so front plane of the assembly, and then the front plane, no, top plane, yes. Goes coincident, and we can accept. And we're not snapping, so it's not solving immediately. I'll go ahead and go between the right plane of the assembly and the right plane of the part. So something's going on with my video card since it's not updating immediately. And let's go ahead and save this as the P5-3. And then at this point I have my orientation, my position set, so I can turn off the origins. Problem with the origin is that they get a little bit, the little blue dots kind of start to take over. So with the 3 items open, we can go to the C bracket and bring it in. I drop this in the work area, then it's free to move. All right, so select Control Select as my other method, and the fastest workflow is going to take me to concentric. Right, part's still able to move and allowed to interfere. And then we can go to coincident. So select Control Select the 2 planar faces. Now we have rotation, so we're gradually getting through the 6 degrees of freedom. And when we reduce this to coincident or parallel, then that will give us a static part. To bring in another instance of the C bracket, then I'm going to hold down the control button and drag into the work area, and we'll go through the same process, concentric between the 2 cylinders, coincident between the faces, and then the prior one I made coincident, but face to face can also be parallel. If I thought that that this bracket may grow or shrink, parallel would be better, because then it wouldn't be in conflict with the concentricity if these faces were no longer able to be coincident. Bringing in another instance of the plate, have the recent documents. And I'm not getting my previews, so let's just search down through here till we find the quad plate. We'll bring it in, pick one of our edges, go coincident. I'm sorry, one of our faces, go cylinder to cylinder, and then I'll rotate over and go cylinder to cylinder. All right, so there's times where there might be a little misalignment, or that the dimensions aren't quite to the same precision between parts, and we could get away with parallel as long as we still have the same alignments. But what I'm building into this model is a certain amount of error checking. If something changes in either the C bracket or the quad plate and it goes to misalignment, it will generate an error, and that error is going to be my first indication that I need to make a correction. All right, so the full list of mates, everything that we've added so far. The C bracket that I put the one coincident on, I want to modify that. So making the modification, going back over to parallel, I'm going to stay consistent between my parts. Underneath the instance of that part, find its mates, and then these are specific mates to that item. No, I don't want to rename it. I need to edit the feature. And instead of coincident, we're just going to shift over to parallel. So as long as the selected geometry is capable of satisfying the conditions of the mate, I can change between mates. If it's something completely different, then we're better off deleting it and adding in the new mate. All right, we'll insert. All right, so you insert components. The peg was open over here as well. Let's do a tile horizontally. And so my assembly is up here. Parts are here. And one of the advantages of tiling horizontally, well, actually we're through with these, so let's make a little more room. Tile horizontally or vertically. Yeah, vertically looks like it'll do a little better. When we tile the views, and I can select edge to edge, I'm going to get an inferred mate relation. So as long as I don't let go of the left mouse button, I can hit the tab. Well, that was the caps lock. I'll hit the tab, and it will reverse the direction and place the peg. Now the peg is still able to rotate, which is why it's underdefined. But if that doesn't bother me, I can leave it. If it does bother me, we're going to expand out and find that concentricity. So the inferred mate is going to, or the smart mate, smart fasteners, yeah, the smart mate or the inferred mate is going to add both the concentric and the coincident. And to keep this from rotating, position is not critical. So I can lock the rotation. That will force it into a fully defined state. Bringing in the next item, we'll go with the traditional control select, drag into the work area. And what the smart mate did automatically, we're going to do manually. So concentric aligns, face to face goes coincident. And then when I expand this out, I can lock the rotation on the concentricity. So we'll go back to the isometric view. Let's see. I'm going to mix it up a little bit again from the file explorer. We'll find the peg and drag it in. If I haven't got the snap, then it's not going to do the smart mate. So we'll go to concentric, go to face, and then let's see, within SolidWorks. Now pretty much the only other one, or one of the other ones, is to bring this in from Windows Explorer. So let's just insert component, bring the peg in, and notice that since we close the other two items, they're no longer present in that open window. Concentric and coincident. And if I come down to the mates, the last concentric, the last two concentricities that I can identify, we can right click, lock rotation, both of those at the same time. All right, so there's my preliminary assembly. To create an exploded view, exploded views are going to live underneath the configurations, and we would want an exploded view to add detail to the drawing package. So under the exploded view, either up on the top or right clicking over here and add exploded view, we're going to go to steps. If I scroll down a little bit, there's going to be an auto spacing of the components. And this is probably a good candidate for the auto spacing. So I want to pick kind of in the order that I would like to drag them. So I have a decent chance for the auto spacing to work. And notice that the last item is stationary. It doesn't need to go. And as I drag those out, then that's going to give me the spacing. Right? So we'll double check the chain by clicking on it. Maybe a little bit wider, so 0.7. Oh yeah, we were going to switch this over to metric. All right, so after the fact, we can go into millimeters, grams, and seconds. Same as the parts, if we edit the document units, it will take us into this screen. 2 decimal places is fine. And that will generate our exploded view. We can collapse the exploded view, and then explode the exploded view, collapse, and work through both of those items. We don't need a separate file for our exploded view. All right, going into the drawing then. At least to begin with, let's pick a standard drawing. It's going to come up with the sheet format and size. Because of the mechanics, all of the associativity, file properties coming over, at least initially I'm going to recommend that you go to a custom sheet size, and the width will be 11 inches by 8.5 inches tall, and we'll go ahead and hit OK. It's going to create a blank sheet, and our border here will update. Our reference will update here in a second. So I'm going to bring in the 5.3, so the model view. We're going to bring in the assembly, and we'll grab first the isometric view. And I can Control C and Control V to make a duplicate, and then we'll come back and show in the exploded state. So I have both of those items. So at this point, for expediency, I'm foregoing the title block. If you like the standard A size title block, it does take up about a quarter of the page. I usually modify the sheet to where it's just the important information across the bottom. So we'll save that for last. All right, so we have our items. We're not so concerned with the size maybe on this one. I do want to generate a bill of materials. So just off screen at the very bottom is tables, and just off screen, let's see if I can get that a little better positioned. No, not quite. Tables, all right, tables and bill of materials. So we'll use the standard. Doesn't really need to be indented, parts only. You can kind of play around with those, see if there's assemblies, sub-assemblies. Then you would want maybe the indented. Since all of these are at the same level, we'll go ahead with parts only and bring in our table. So at this point I haven't added a description. I just need basic quantities and what the part is. And really this is the file name, not necessarily the part number. And I'm going to delete the column so that it cleans up a little bit. And then going back into that view, make sure it's highlighted when I tell it to auto balloon. And the auto balloon I will load to the left. That's not too bad. See what it looks like to the right. Okay, maybe to the right. Alright, so those jumped a little weird, so I'm going to put it back onto the magnet bar. And the magnet bar moves all of the items together. And since this was picking for the edges, filter, and I can drag to a better location. And then the magnet line can shrink or expand and position it as needed. All right, adding the next sheet. All right, so there's two methods, and I think the one part or assembly per file is pretty straightforward. You would just save this one, open up again a new sheet format, put in the next part, save, open up a new shave. I prefer the drawing packages, so when I add a sheet, it's bringing over the previous sheet, and now I can insert for the bracket. So traditionally it's been the view layout, model view, or insert drawing view model will both get you to the same place. And we have the peg open but not the quad plate. So first item that I would pick up would be a quad plate, so I can select for it and then pick the views. I want to create a multi-view and don't know that I need all of these, and kind of just doing a quick look at the preview. The basic rule is that I'm looking at the front and then the top and the right. If I'm not going to put a dimension on one of these views, then I really don't need it. So I'm thinking that I will forego the top view, and everything will stay with scale, and we'll go ahead and accept. All right, so this puts in the center marks. We'll put a few dimensions on this. So I have my overall, and would like to have a little more contrast if we have a color printer. Well, the layers are up. If the layers are not available, then we'll right click and the gray area and come down to the layer, make sure that it's checked. Then that will open up this this window just off screen, and we'll make new, and we'll just call it dims, and I can set the color. I think it's usually that one I like for my dimensions. And now we'll put in, and that one didn't pick up. Okay, so I think I encountered this before and I don't remember how I saw it. So we're going to go ahead with leaving it on that layer until I can make the correction. All right, so one of the things to watch out for then, oh, and we're still in an inch. Well, we'll come back and fix that one. And notice that I'm in the ISO drawing standard. So my vertical dimensions are in line with the extension lines. If you have a preference, then we can edit the document units. Come back to the drafting standard, switch over to ANSI, and that will align the dimensions in between the extension lines. All right, so one of the things we'll watch out for is chain dimensioning. When I bring in the first instance, or first dimension, if I were to go between center marks, then I would have an accumulation of tolerance. So if this shifted 10 thousandths, and then this dimension shifted 10 thousandths, and the next dimension shifted 10 thousandths, and the next dimension could shift 10 thousandths, we could have an accumulated dimension of 40 thousandths at the last. So for reference, we could put a typical on this, but we're better off. Oops, and I missed. And notice I'm trying to grab the center mark extensions. If you don't get the center marks themselves, then go between the circles. And if you're going to use min-max, make sure that you're on the circles. So baseline dimensioning is going to be a preferred method, because then each of the individual holes can only shift within its tolerance a max of 10 thousandths, not the accumulated tolerance of all the holes. And then to set the diameter, we pick one of them, and if we want to add the note for the 4 times, I'm not quite in the habit of grabbing the little box. And that's not really where I wanted to put it. Text on bottom, text on top, text on left, so 4 times, diameter of 39, 10 millimeters. All right, and then our thickness, and I'll pull that off to the side. Let's see, wanted to go Yeah, so we'll go to the document units. Under dimensions, you'll be able to set dual dimensions. And I would like my dual dimensions on the bottom. So if I was in metric, I could put the inches on the bottom. Since I am in inches, then I'll put the metric on the bottom. It does require that we do a little spacing, and we'll reposition just a little bit to kind of clean up the move. All right, so notice that the views move together, and so when I position the parent view, the front view in this case, then the right side view is going to move with it. It can only move in line, left to right, not up and down, because of the alignment. Next, we'll go over to the C bracket, and that one will go to the view palette instead. So view palette, pick the item that we want. Since it's not loaded, the ... browse. Pick up the C bracket and go ahead and open. And then I can bring in the front view. And it wasn't set to automatically auto start projected view. So I was expecting it to bring in my next view. Since it didn't, we'll go over to view layout, projected view, select the view, and we'll get those in place. All right, so again, I don't know that I need, yeah, I do need the top view, the through hole. So projected view, and then we have that view. All right, so our dimensions, back to annotations, smart dimension. All right, so 10 millimeters, and can't say that I like that that placement, so I'm going to Control Z. Visually, I don't know that it makes more sense over here, but I'm going to put it in. Pick up the center line, and then off of one of the edges, put in the other 10 millimeters. Okay, and then we'll go, if we don't go to the box, then we'll come over to the dimension text 3 times and accept. All right, so since the view, my general process for hidden lines is that if it adds something to the view and doesn't make them more distracting, then we'll go ahead and put those in place. All right, so not sure what I did there. Make sure that it's, we'll just use the parent style and stay with the parent style. So that'll give us our views. So notice that the quad, this one did not pick up the hidden lines. And when we switch over, it's not using the parent style, so we'll have to activate that. All right, if we set that as the default for the insert, then we'd automatically get those. But depending on the complexity of the part, they can get quite complicated. And if it makes the drawing busier, then I will decide if they're helping or they're hurting. All right, so location, got the locations, got the sizes, do a little cleanup, and then last will be the peg. So let's try the view palette again with the auto project on, and we'll go peg 10 by 20. Let's go ahead and bring in the front view, and we'll auto project to the side. And the reason that I did this is that I want to be able to rotate. So if I need to rotate the view, we'll come up to the heads-up display, rotate view, and a little pop-up will show up that we can rotate 90 degrees and apply. It warns me that this view is going to be updated, and then it will turn to the end view for the cylinder. When I go to the projected view, then we're pulling the isometric view off. And for scale, I could go through each item, each view, and set its scale to a custom scale. Oh, here we go. On 2017, we can come down to the status bar, and if we go 2:1, that'll make it a little bit bigger. Or I can right-click in the area and go to Properties. If Properties does not show up, then we're going to go to the very bottom, Customize menu, and make sure that Properties is shown. Right, so if I go into the Properties, we get the sheet properties pop up, and then I can set a scale if I wanted, and don't know why, but if I wanted 3 to 2, apply changes. Now it shows up as 3 to 2 in the scale. All right, so a little bit bigger, 2:1. Back into the annotations, set the dimensions. We set our parts. All right, so we have now a drawing package that has, this is how it goes together. These are the parts that we're making for it, but we don't have any notation on this sheet. So at the upper limit, or at the upper end of the capabilities, I would have all of these parts with their individual file properties populate the title block myself. Again, for expediency, we're going to go into Note and start to think about what items are going to be beneficial to have. So first pass through, if this isn't already set up for us, and it's not, then we'll think about the file name. And that one's showing up in the dim. And I'm going to go to the link, pick the model found here, drawing view specified in sheet properties, and we'll go to a property name and pick the file name. Hit OK. So assembly file name 5.3. We haven't set any materials or any other additional properties, so that would be one we'd want to look at. So material is, well, nope, this is for the assembly. This varies. You know, maybe a date. And rev. And a drawn by. Okay, so we can populate those manually, put it into the box. I believe the note will pick up. See, zone locations. No, I was going to look for the border, and then you could put a box around it if you wanted to have a little more definition with 0.1 of padding. Opens it up a little bit. I'm going to stay with none. All right, so I would like to have that reproduce. So Control C, Control V, and it did. All right, so you should have installed 2017 Service Pack 5. So Service Pack 5. And this was one of the issues that I ran into last semester, where under the options in Service Pack 3 there was not a document properties for the drawing sheets. Use custom property values from this sheet on all sheets from sheet number 1. So if you want all of them identical, then check the box. We uncheck the box, then let's see, we should be able to do the rebuild. Or not. Let's see, file name. No, that's still the file name. So, oh, we haven't named the drawing yet. All right, so I have one more item that I have to put in there. I got ahead of myself. Okay, so part name. Go back into the to the link to property, model found here, drawing specified in sheet properties, and then the property name now becomes that was the current document, and that would be the drawing name. Okay, so apparently that isn't quite what I'm expecting it to do. All right, so let's go ahead and save. All right, so I'm going to make it just a little bit different so we can see the difference. And the file name. All right, so one more thing in the properties then that was set, same as sheet. No. And default. Okay, we'll reproduce that again. All right, so maybe it didn't get corrected as much as I thought. All right, so that one came up with the quad plate. All right, so that one came up correct. So let's give it a chance to rebuild. And I'll do a control Q this time, which forces everything to rebuild. Double click. Make sure that I'm not carrying it over to property, model found here, sheet properties. So I'm still getting that carryover. All right, so let's save it. That one updated correctly, so that one in its sheet properties, SW file name, file name. All right, so I'm gonna have to catch up to that one. All right, but that'll give you the basics to start. Worst case, I'm gonna go in, I'm gonna take that P5-3, break the link and type in the C bracket. But I want to at least have, want you to have at least a basic understanding of the associativity. All right, so that gets us a drawing to start. At this point, if you want to take it further, we can start to sketch in. There's a whole nother discussion on drawing templates. So let's make sure to save that. Close it real quick and see if opening it back up. Open recent. It's not picking up my links, so oh, okay, so it was a carryover. So one more, properties. Let's just go ahead and all right, so that I'm buying. All right, so we'll go ahead and save that out. All right, so you have a working drawing. The views are specific to the part. We're looking at the front. Rotating it over, we're looking at the side, or the top. Rotating it over to the side, we're looking at the right. And as you move through those, that is going to give you your third angle projections, and then of course the isometric view. So considerations for the 3D printing. Orientation, and we'll do this as a single unit first. If I just wanted to see all of this piece in one print, no clearances, not disassemblable, then I would consider what I'm testing for. And if the loading is in this direction, I would want the layers to run horizontally. Okay, so across the length of the part. If our loading was through the ends, then I would want to build this way. The problem is going to be having the support structures in the middle to bridge this gap. So printing it on the side would be an option. I would have the items running this way, but I want to think in terms of where those boundary layers between each of the filament is going to separate to get some reasonably accurate loading. Right, so picking your position is fairly important. Doing the save as, then, if I output this to an STL file, there are going to be times, and I went to the options, there are going to be times where fine and coarse are probably within the tolerance of the thickness of the filament. We're outputting to millimeters. Most of the slicers will rotate to position for you, but if you can output it in the position, we might set up a special coordinate system, which is going to be under, let's see, reference geometry and coordinate system, picking a new point. And then going custom and setting the tolerance even finer doesn't necessarily give you better resolution on the printer. It makes a larger file and more for the calculation. Oh, the other one then was, do you want to save all components of an assembly in a single file? That would make just that unit. Or if we uncheck that, then it will save the 3 individual STL files, and I wouldn't necessarily have to open up each of the part files individually to get them to save out. So let's go ahead and save, and yes, and then let's find that file. All right, so on the other side is, since there were a total of whatever 7 or 8 parts, I got 7 or 8 STL files. So I really only need one of those, and one of those. So pick your method. Opening up a file is, or opening up a part is as easy as right-clicking and open part. And then saving the, and then same thing, file save as. Since we're going to a translation, don't really care. If I was saving it to be reused, then that would be a little bit different. Same with the options. And check your tolerances and coordinate system, and then we could just save it out. All right, so gives you a couple options for 3D printing this item. And then let's see, let's go ahead and control. All right, so all the minus signs over here, and that kind of freaked me out. So I'll do the rebuild, control Q, or come up to the green light and rebuild. So let's look at this from basic simulation. All right, so SOLIDWORKS simulation, FEA, so our finite element analysis, is going to bring us a couple of items depending on the level. If we are in a commercial environment with only professional level, then we would have access to Flow Express, which would be a single body within a part, applying a load to our geometry. All right, so we have the simulation at the premium level. Then you have a static loading within an assembly, and then going to simulation level 1. I tend to stay away from the simulation advisor and just go to new study, go through each of the items. Try the advisor, but I think you'll find that picking your study is easier than once you've gone through the explanations a couple of times. All right, so once you get to simulation level 1, then you have static, thermal, frequency, all of these guys. The nonlinear and linear dynamic are simulation professional. Each of those is a step up in capabilities and a step up in cost. The education version should have everything available to you. Most of the additional studies require that you have the static established as loading what's fixed, and then you can put in thermal quantities and look for the frequency of the system. All right, so static 1, I have not set any materials. So I ran through this and everything's set to whatever, but we did not pick any materials for these items, so that's going to be a little bit of a problem. So I come over here, we'll get that back out of the way. Oh, jump over to the model then. And the plate quad was defined as, they're saying 1040 steel. There's not going to be a significant loading difference between that and 1020. So apply 1020 or 1020 cold rolled. So once I apply it to one instance, then the next quad plate is also going to pick it up. And then see, is it available? No. So edit material and collapsing, cycling through to be able to find the other materials. If not, then we'll have to find specifications for that material and enter it manually. But there's usually a broad enough range that you can find something close and go through the process. All right, so determining what this is going to do. We'll go back into the new study, and already I want to make this more complicated than it's worth. So realistically, if our concern was in and around the C bracket, we could almost cut this in half and ignore some of the parts. Looking at a cross section would probably give us a good sense of where the gross errors are. Running it through the mesh and picking up all the items, that'll take a little bit longer. But until we get to that point where we're a little more comfortable with what the design goals are, we'll let it mesh everything. All right, so got my material set. There's nothing, none of the components are without check marks. Contacts are global, so there's no gap tolerances or anything left between the parts at this point. Otherwise, we'd have to tell the software how to account for the fixtures, fixed geometry. We're going to put on the base. Oh, it's automatically splitting. There we go. All right, so fixed geometry, faced, and don't really need to split anything at this point. All right, so split would be if we had a contact area. I wanted to put a little circle where a pin is going to come down and push, and I want to see the deformation. If I use this as my total loading, then I'm going to get full contact across that face, not a point of contact within that region. All right, external load. Not so concerned with gravity here. We'll put a force and split on me again. All right, so when the screen is a little bit bigger, not dealing with the video capture, that split is going to take up less of the screen. But keep in mind the little bar with the dot is going to switch you between Property Manager and the simulation, or let you be able to resize. All right, so let's see, our steel 30 millimeters inch and all right, so let's put 1,000 newtons on it per item. So there's not a switch. If I had full contact across here, I don't know that the pegs even really play a part, but where per item comes in is now I have 1,000 newtons, 1,000 newtons, and 1,000 newtons. Total is across that entire surface. Right, so keep those values in mind when you're setting for your geometry. Okay, we'll span that back up and we'll run through the mesh. Usually I'll create the mesh first and we'll save that out. So again, have to manipulate. Go to the course side, and we don't really get percentages or anything. It's kind of a guess. I'll set a course mesh to look for, again, a gross error that is going to help me identify places. Okay, we have a stress riser. We have, we have these contact areas. Where do I need to start looking without having to run a detailed study? All right, and then we'll run the study. I should have saved, but this isn't that complicated. And we look at the deformation. So the deformation is pretty dramatic until you look at the deformation scale and realize 978 times. And we come over to the von Mises stresses, internal stresses. And then let's see, we need to switch back. All right, so let's see, where did we're still in static. Oh, too many things going on the screen. There we go. Let's pull that one back up. It's a little easier when I have the higher resolution screen going. So displacement, also at full scale, but then you look at the millimeters. So red is at the 1.4 to the -2. So move those over, 0.014. It's a very small amount, even though we're looking at that deformation as being dramatic. And then the strains into the corners, obviously at the stress risers and the internal segments at the top side, gives us a pretty clear sense. So adding, usually the one I want to add is a factor of safety plot. And let's pull down. And we're going all, not really just not singling out any part. We'll stay with multiplication factor. Areas below a factor of safety of, well, let's go 10. Minimum factor of safety is 17.5. So we could definitely at 1,000 newtons reduce that. So let's get closer to see what it looks like at the 20 range. Factor of safety distribution and areas below factor of safety of 20. Well, that would show up everything as red. So let's go 18. All right, so everything shows up red. Minimal in the middle where it's coming back. Edit definition. Bring it back down. Yeah, I can see where that's going to get kind of annoying. Yep. How about 20 instead of 120? All right, so factor of safety of 20. Pretty much everything right around the holes and in the stress risers in the corner. All right, so that should give you an overview. I will put the video links to more detail. My expectation is that you will use this as a good starter place to ask questions and start to learn or build on your terminology and be able to perform some of these basic